I am building just a behemoth of a battery for the electric bike build we're doing on this channel. This video covers the whole build up to this point and the failures and learning experiences we had along the way. So if you're planning on building an electric bike battery anytime soon, you're going to want to watch this one. So to start this build, I drew up the battery in CAD based off of my measurements in the frame where I could fit it. Then I had my custom battery cell holders manufactured here locally. There was a shop here that had a CNC router and was able to cut them out of ABS for me. I think a 3D printer would have worked great too. It's time. So now we go straight to the fun part. That was sarcastic, in case that wasn't obvious. I am assembling each individual cell into the battery cell holders. You can notice I am being very particular about the orientation of each cell, and I have the CAD pulled up next to me to show me which cell goes in what orientation. This is really important because that's how you make your different parallel and series connections. You can see that the cells facing the same direction go in like strips for most of it. The reason I designed the battery that way is because I want my parallel connections to be super long and skinny so that my series connections can be just as wide as possible. The parallel connections are only balancing the cells that are in that parallel pack, so it's a very small amount of amps going between them. The series connections have to take the full force of the amps of the whole battery, so they really need to have a whole lot of connection area to be able to pass all those beans along. The cells I'm using for this are the Samsung 50S. I have a whole video that goes into if you should run these cells or not. They can be great and they can be terrible, and it's a very controversial subject. So be sure to check out that video after this one. But now I am installing my copper connections. I got these from a place in China. They overall did really good. I sent them CAD and they were very good at communication, and Ken walked me through the stuff that they needed and got me the parts that I needed. They messed up 2 different times and I had to wait on new shipments from China twice. So that was definitely not ideal. But overall, I couldn't have done it without these connections and get the amps that I have if I was trying to do like the copper nickel sandwich. You may be wondering why I am skipping over a couple connections, and those connections are the positive and negative posts and my crossover connection. Those bus bars require soldering, and it's important that you do any soldering work before you spot weld them to your battery cells to keep heat out of them, especially with the amount of soldering that I have to do. So we got our 2 connectors here. These are the ones that are gonna be crossing over a series connection, and we're just going to solder a bunch of these little copper braided chunks onto there. I'm just gonna hold it in place with this little clip. I got it spaced apart with these little paint sticks. That gives me about the right thickness. It's a little bit over, which will be good because then it will just make the copper braid expand a little bit when it gets pushed together farther rather than pulling on it. I don't want it to be pulling on that. I want the rest of the housing to be holding in place. I never want my connections to be holding anything in place. All right, let's see how this goes. This thing gets like wicked hot, and then touch it to the copper and all that copper braid and all this copper here that just sucks the heat right out of it so fast. Okay, I shouldn't do this, but I'm going to get my torch and bring it in my office. If this does actually work good, then I will take it out of my office, but we're gonna test it out in here real quick. Just really low. I'll probably get the soldering iron back in here. There you go, look at that. That's what it's supposed to be doing. Problem is, it's hard to get solder on it with the torch. It's looking like we're gonna have to do some kind of garbage solder joints with the soldering iron and then come back through with the torch and make them actually good. Okay, fast forward a bit there, and this thing is all soldered up. It's not the prettiest thing, but every once in a while, functionality has to come over looking pretty. So, gonna have to kind of loosen up the middle bit here. This is kind of a test run of sorts because I've never seen this done before with copper braid. I wouldn't be surprised if it has been done, but I've never seen it. I had seen some copper braid connections in the past just for adding extra beef to welds, but I hadn't seen anyone try to make a bendable joint out of them. And I think the reason is probably just because of this right here. It's really hard to bend it once you get it covered in solder. But we'll see if we can do it without weakening that copper too much. It is doing it. Looks like we got it to bend good. It's definitely not the kind of thing that you can just bend back and forth a whole bunch of times, but we just need to bend it open, weld it on, and then close it up just one time. So I think it should work good. Okay, we got the K-weld hooked back up over here, and we're going to weld this sucker on, starting with this side of the battery. Our foot pedal lined up down here. Make sure it's lined up on this side. Go ahead and throw a weld on this one. Quick tip on spot welding. I was sometimes putting a single spot weld on a spot that needed two, and just to hold it in place while I did the rest, because I didn't want to just be jumping all over the place. I was like, oh, I'll just throw a spot weld here and then move on to other ones. And then when I went through and did a super thorough check to make sure that I got every connection spot welded, I found a couple that I forgot to go back and fix. So it could have been bad. And that also tells you that you should go back and check everything really closely. You don't want to leave off any welds or screw any of them up. Could be really bad. I had a bit of a spark when I hooked it up. I'm not sure what that means. Okay, breaking out the old multimeter. Should probably get a new one by now, but hasn't let me down yet, so I'm still using it. Okay, so getting 48.3 on that one. 48.3 on that one. So there shouldn't be a serious drop between them. I have everything hooked up right. Alright, I need to step back for a second and check the voltage of each individual cell in this pack, because in one direction we are making a series connection with the battery, with the two battery halves, but we're also making a parallel connection between each of these cells. And so I'm thinking one of those is out of balance with the rest, or something to that effect. They're all connected on the negative side, so I can just put one lead right here. And then check, it's 3.4, 3.4, 3.4, 3.4. I'm not going to keep saying it, but there's still 3.4. Yeah. Okay, I feel like a moron. Found out why it was sparking. So this piece right here hangs down. When I pushed it all the way down into place, it wouldn't spark. But if I was like kind of moving it around, every once in a while it'd spark and freak me out. And you can see right there, those sparks. They happened like 3 different times and I couldn't figure out why. So right here, that's where it was sparking, on the side of that cell. Ugh. That's scary stuff. That's how people start fires, and everything in this pack is glued together and spot welded together. So if one of these cells would have caught on fire, I would have had quite the fire on my hands. I'm gonna cover that up with some Kapton tape and then stick one of these foam pieces in front of it so that it can't rip the Kapton tape, and then gonna keep going with the spot welding. Okay, the foam wouldn't fit, but we got the Kapton tape on there, and now I know what to look out for, so we can keep this better into place. That just shocks me. Making all sorts of dumb mistakes here. Okay, so that part should be safe there. I'm gonna have to open this back up a bit to put on these connections once they're soldered, but I really want to get it closed for now so that I can focus on the issue that I just saw with it grounding to the positive there. I want to get that covered up really nice before that has the chance to spark again. So we're gonna get this picked up here. Just shocked me again. Gosh, I need to keep my fingers out of there. Okay, so let's discuss this problem. So I need to find a good way to insulate these from ever contacting with these side pieces. For some reason, I did not think about that at all in the battery design, and I'm now realizing how horrible that could be. So thinking I can do a layer of Kapton tape, which will cover it up as long as it doesn't get cut again, but it could easily be cut through again, just like this stuff. So then I'm thinking of stuffing one of these acrylic panels in between there. The same stuff I made these covers out of. These are going, there's one on the inside, and then I'm putting one on either side on the outside with the foam between this and the battery. But then on the side here, I'm thinking I could just, because this stuff's really thin, I could just sneak some of that in, just like this, and that should stop it from ever wearing through.
Shut up, you love the music. I don't want to hear anyone complaining in the comments about the music. It's dope. But anywhom, this entire time I recorded the next like 7 sections, my mic was off. So that was cool. I also recorded like 2 different times of me explaining what I was doing. Mic was off for all of that. So coming back in to explain it retrospectively, I have the negative terminal here, and I am soldering on the negative wires. I had some learning experiences with how crappy it is to solder this on, so I eventually ended up just piling the solder onto the wires and then heating it up with the torch to stick it on. Took a couple tries with a couple to get enough solder to stick on well enough. But eventually got it real nice, touched it up a little bit in the corners, and then we were able to move on to the positive connection. That's what we're doing right here. This is one big long wire on this side because we have one output. I did 3 on the negative because it's going up to 3 different terminals on the BMS.
So what I did on this one was I used some stainless steel wire and just kind of tied it into place so that those different little strands of the cable wouldn't just like flying everywhere. It worked well, but trying to fill it with solder in here was super crappy. I ended up melting the little rubber jaws on my vise, obviously. So I moved out to the shop finally, like I was supposed to do beforehand when I was soldering with the torch, and loaded this with like 1.5 pounds of solder just to get it stuck on there. I couldn't believe how much solder this thing used. That roll was like full when I started and almost empty when I ended. But eventually we got it. It kind of looks, it's pretty ugly, but it works. It again, functionality needs to come over looking pretty every once in a while, but it's fine. So got it spot welded on to the battery on that side. That's the negative, and then do the same thing on the positive side. Get that thing spot welded on. Man, you're really missing the music right now, aren't you? You're just thinking, man, I wish I was listening to that sweet music instead of this guy's stupid voice. I know. Don't worry, I'll probably add some music later on. You'll hear it again. So get that thing taped up and then fold it back over again, but I forgot the little stuff that goes inside, so I gotta pack that in while I'm holding it in the air. Fold it over the rest of the way. I folded this thing in and out like so many different times. It's stupid. Okay, so we need to attach all of these BMS wires. I got them plugged in because it makes it a little bit easier to keep track of everything. They're all white wires, but then there's a red and a black on either end here. That's obviously your positive and your negative. So you start by hooking the negative to the negative, and then the first wire in the pack attaches to the positive side of those cells in the negative end, and then so on and so forth from that one up to this one, and then from this one up to this one, all the way down and around until you get to here, and then you actually put the last balancing wire on the positive post, and then you also put the positive on the same post. So this is a 30S controller, which means that I will have 2 wires left over right here. Let's see. Jeez. These 2 wires shouldn't be going to anything. And then I also have the communication wires will be right here, and the temp sensors plug in under here. So should be good to get going on this. I did Kapton tape everything already, and I'm gonna have to peel that back, but I figured it was worth it because I didn't want anything to touch anything that it shouldn't in the meantime. I still don't want to solder even to the connections now that they're attached to the batteries because they're really good at conducting heat. So I'm going to spot weld on this 0.15 millimeter nickel strip to the copper connection, and then that'll stick out the top, and then I can fold the battery back together, mount the BMS in place, and route each one of these wires and just solder it to the nickel strip. Okay, folding back up now. Hopefully for the last time. You can see all the connectors poking through right there. That's just what we want. It's looking real good. Still don't have any damage on these, it looks like. Nice. Got across there. Well, I did about the stupidest thing I've ever done in my whole life. I accidentally tried to weld my BMS to my battery here. This is the position that I have been planning on putting my BMS. It's right there. And so I keep setting it there and measuring the wires and everything and seeing how it's gonna fit up. So once I got these tabs welded on, I decided to do the same thing to see where I'm gonna run the balancing wires. And well, I welded the BMS to these little balancing wire tabs. They're right there. Yeah, it's an obvious, stupid, dumb thing. And yeah, I knew those had power in them. I knew not to touch them. And then just for a split second, I decided that I needed to put that up there again. None of the cells lit on fire or anything. And it seems to be holding up just fine. I checked voltage. I still have the same voltage and everything. But obviously, some of those cells were damaged. I'm sure I'm not going to get the capacity out of them that I would have if I didn't do the stupid thing. It's happened now, so all we can do is just move forward. Hopefully we'll still get close to the same capacity that I was hoping, but obviously, yeah, the damaged cells are not going to do as well. I'm going to have to fold this thing open again for like the 4th time now, because a couple of those tabs got shredded. This is that connection that really got it the worst. It took it right down to the connector there, and you can see it took chunks out of the connector too. Okay, fast forward ahead a little bit here. So I got the new connections added on here for the balancing wires. It went well. I was gonna just replace this one, but these two had just some gunk on them that was making it hard to solder, so I went ahead and replaced those two also while I was there. Turned out good. Got those soldered up nice. It just happens to be that of these 4 connections, they use 3 different plugs, so that made it real nice. Just happens to be the spot right there where they all come together. But nonetheless, that's taped up and good to go. So what we're going to do next is we're going to try to not re-weld the BMS to the battery. So I'm going to stick some foam back here so that, I mean, it has this Teflon tape over the top of it, but just to be 100% sure, I'm going to stick that foam there too so that it can't wear through. And then I'm also going to clean up some of this crap first. But then once that's there, then we can make some prettier BMS wiring to each of these other spots. But before we do that, I'm gonna just temporarily cover up these connections so I don't have a repeat, and we're gonna attach all the outside connections. And then once I put the BMS on, we can solder them all together at the same time. Okay, so while I get all these connections made for the balance wires, I just wanted to say real quickly, if there's information that you're looking for that you haven't found in this video yet, there's a good chance that I covered it in the everything that you need to know to build your own battery video. There's other videos like that cell comparison video and the build kickoff where I talk more specifically about detailed things and about my build, but I tried to cover everything generally in that one video. Otherwise, feel free to leave a comment or join the Facebook group and post questions in there, and get a hold of me any way that you can, and I'd love to help you. And there's plenty of other people in the world that would love to do that also. This is a fun community that loves sharing experience. And since I haven't said the specs of this battery yet in this video, I realized it is a 7.3 kilowatt hour, 104 volt nominal, 70 amp hour battery. I'm attaching this acrylic panel and then covering it in tape. That is because these connections are just absurdly close to that aluminum faceplate. I don't know why that's the case. It seems exceedingly dumb. Like that could easily make a connection and short out the whole battery and light your genitalia on fire. All right, if you've made it this far in the video, I just want to say I really appreciate you. It helps a lot. Put a lot of work into these videos, especially this one's taking a lot of work. So just want to show this is where we're at with the battery right now. It's got the negative connection made to the BMS. All the balancing wires are connected. The positive wire here is ready to go to the controller. We got it hooked to the BMS app, and that was a whole project in of itself, it felt like. It was a little weird, and I'm gonna make another video just on that. But for now, I think I wanna end this video here. We're also doing the enclosure. I wanted to get the battery actually built just in case sizes are a little different than I was planning on. So now I'm editing the model for the enclosure, and I'm going to have that sent off to be laser cut. And then we'll be waiting on that to ship to us, and we'll be mounting the motor at the same time. I'm also designing the mounts for that. Hopefully doing a video showing kind of my design process and how I'm building the mounts and stuff, because I think that is fun. If this video is helpful, please leave it a like. And if you want to see the rest of this battery build and us mounting it into the bike and testing it and seeing how it actually does, you'll want to subscribe, follow along, and I'd appreciate it if you did. Obviously, if you don't want to see that, then you probably shouldn't subscribe. But I'm really happy with where it is right now. It's all showing what it should on the BMS app. So very happy with it. And we're ready to keep moving forward on this. So thanks again, and we'll see you on the next one.